This video is made as part of final assignment of Foundation Design course from Skylab. In this video, we'll try to understand problem statement by already done a 23-story building in ETAP. The actual forces at base of column which is transmitted to footing, column dimensions, column material specifications, position of column, all these details we will note it from ETAB for problem statement. Now here already I opened a 23-story building done earlier in ETAB. Now we wanted to know actual loads. For that we will go to Model Explorer. From here tables, then analysis and a result, frame result, column forces. A table of this type is displayed. We will shift to okay. From here we will right click. Here it is seen that story 23 is there. So we wanted to go to story 1. So right click here, story 1 select. Now story 1 is displayed. Then we will go to load case oblique combo. Here load case, right click. We now take dead load. Now it is shown all dead loads in column, in various columns at base level. Now we want to go station, right click, sort ascending. Now at 0 level, all the dead loads of column C1 to C16, total C16 columns, then C1 is repeated. C1 to C16 is shown here. Now this is the actual dead load of respective column. For column C1, the dead load of 1671.8559 is there. Likewise, for column C2, a dead load of 2745.404 actual load is there. So we will note down all these loads, and likewise we will now change it to live loads as we need live load. So again we will go to story 1. Okay, load combo is live. Now live load is given here, this column. Station we will filter, sort ascending. Now C1 to C16 column is shown here. This is live load and story number 1. This in story 1's column 1, live load is 786.6694. So we will note down all these loads, actual loads. live loads and dead loads both are there. So we will now close it. Now we will check the position of column layout. For that we will go to detailing. If detailing is not there, then we will go to detailing and then it is will display. Now detailing drawing sheet, concrete column layout, concrete column layout. Here as seen, this is column C1, this is C2, this is C3, this is C4. Likewise, we will note all columns numbers in the and note it down. Now for column size dimensions, we will go to Model Explorer, Model, Structural Object, Structural Object, Story 1, then columns. Now double click C1. Here column story 1, column C1, size C500 by 500 is given. Cancel. C2, for C2, this is his column C2, and column dimension is say 500 by 500 millimeter. That is makes it now column. Likewise, we will check all columns. This is also C500 by 500. C4 is also 500 by 500. C5 is also 500 by 500. C6 also, C6 is 600 by 600 millimeter. C7 is 600 by 600 millimeter. C8 500 by 500 millimeter. C9 500 by 500 millimeter. C10 600 by 600 millimeter. C11 600 by 600 millimeter. C12 500 by 500 millimeter. C13 500 by 500 millimeter. C14 500 by 500 millimeter. C15 500 to 500 millimeter. C16 500 to 500 millimeter. In this we come to know that only 4 columns C6, C7, C10, C11 all 4 columns are of size 600 millimeter by 600 millimeter and all other columns are of dimensions 500 by 500 millimeter. Now we wanted to know the frame material specification which is used. For that we will go to define section properties, frame section. Here column 500 by 500 and column 600 by 600 is used, so we will note down column 500 by 500. Here M40 material is used and reinforcement is given HYSD 500. Okay. So next C column 600 by 600 we will check. Here also M40 concrete is used and reinforcement HYSD 500 rebar is used. So now we come to know all the details which we required for this project. Now we will make problem statement is now here. Uh, this is the problem statement that we are having. This is the plan, and the column position is C1 is here, C2, C3, C4 is in this line, C5, C6, C7, C8 is in this line, C9, C10, C11, C12 in this line, like this, and C13, C14, C15, C16 are in this line. And the position of all columns are clearly mentioned in here. Now we have given soil bearing capacity as 300 kilonewton per meter squared. Allowable settlement is 1 centimeter. From this, we calculate subgrade modulus. That subgrade modulus is calculated by soil bearing capacity divided by allowable settlement. That is 300 kilonewton per meter squared by 1 centimeter. That is 3 the 10 the power 4 kilonewton per meter squared. Now column strip width we have to be decided. So for that 0.25 L1 or 0.25 L2, whichever is less to be taken. Now in our plan, both sides 18 meter long. So we will take 0.25 into 0.25 into 18, that is 4.5 meter. We will take 4 meter as column strip width, and also from the we from the GitHub we have noted all the actual loads and summarized like this. Column C1 dimension 500 millimeter by 500 millimeter. It has a dead load of 1850 kilonewton, live load of 797.6. The material used is M40 concrete and HYSD 500 rebars. Likewise, C2, this is also 500 by 500 millimeter. The dead load is like this, and all the up to column number 16 we will make, we noted and made this chart. Now we will start designing through safe software. Now I already opened the safe software here. Here we will going to file new model. Design code is to be changed as IS 456 200. Here design preference modify or minimum cover slabs we have to be given 50 for footing, 50. Here we will give 22. Preferred bar size will be given 22. Okay. Units currently metric. It should be in metric. Okay, metric grid only. Now, number of grid lines, we are giving 1 meter grids. We have 18 meter. So grid lines in x direction will be 18 plus 1, 19, 19. Same as for y direction, it is 19. And grid spacing will be 1 meter. And in y direction it is also 1 meter. Click on OK. Now, as per our a grid is formed. Now we will define materials. Materials. Add new material. Here we will give M40. This is concrete. Weight per unit volume will be 25. Modulus of elasticity will be 31,622.7. Coefficient of thermal expansion 0.000055. Concrete cube compressive strength is 40. Click on OK. Now add new material for HYSD 500. Here name will be HYSD 500. This is a rebar. Weight per unit volume will 77. Modulus of elasticity with 2 lakh. Minimum yield stress is 500. Minimum tensile stress is 545. Click on OK. Material is assigned. Now we will assign slab, define slab properties. Define slab properties. There is no slab add new property. We'll give name as mat footing. Mat. Mat footing. This is M40. We will give thickness 500 initially. Click on OK. OK. Now we will define column properties. Column, add new property. Column, this will be 500 by 500 mm. 500 by 500. This is M40 material. Here 500. Here also 500. Click on OK. Add new property. Column, this time it's 600 by 600. This material is M40. Here is 600 and here also will be 600. Click on OK. Now we will define soil subgrade properties. Define soil subgrade properties. The soil one is there. We will modify it. Here our subgrade modulus is 3e. That will be changed and it's OK. OK. Now we will check load patterns. Is dead and live load one. It's okay. Now we'll check load cases. Is linear static load case is okay. Now we will go load combinations, add new combo. Here the 1.5 is the scale factor. Here we will give live load, that is 1.5. Design selection will strength, like it okay. Add new load combination 2. Here we will give dead load scale factor 1. Here we will give live load, that is also scale factor 1. Design selection, service normal, service initial, service long time is okay. Okay. Now we will draw slab areas. Draw slab. This draw slab. Here it is mat footing is given. So we will select this is the one. Here from here this then here. Okay. Here, 18. Now slab is drawn. Now we have to be extend this 2 meter on both sides so that the column can be covered by the footing. For that we will click the footing area. So one area selected. Now we will go to edit menu, edit areas, expand or string areas. This is value will be into mm, so 2 meter is equal to 2000 mm. We will give 2000 offset value. Just okay. Now it will be the footing size is will be 20, 22 by 22 meter. Now we will draw columns. 500 by 500 columns. We have 12 500 by 500 millimeter columns and 4 600 by 600 millimeter columns. First of all, we will draw 500 by 500 columns. For that, we will go to draw columns. Here, property below none, property above column 500 by 500, height below 0, height above we will give 2 meter. Now we will make the first one is here. From here, see here the second, here the third. Now we will change the column to all the 500 millimeter by 500 millimeter column was drawn. Now we will draw column 600 by 600. Now all the columns are drawn. Now we will draw design strip. For that we will go to draw design strips. Here in strip layer A we will 4 meter. Where it is 2. Sorry, it's 4 meter, 4 meter. Like will be likewise we will strip layer B will be drawn. Design strip are drawn. Now close this. Now click on a footing area in one area is selected. We will assign soil data. For that, assign support data, soil properties, soil 1. Soil 1 is selected. For strip view, we will set display options to design strip objects. This is the strip we are given as shown. Now undo. Okay. Now we will go loads to each column. So here column size are for 12 column sizes are same but loads are different. So we will select each column and assign loads. For that we will select each column. Now for 7, for that C1 one will assign load data oil loads, dead load, gravity for C1 8050. The size is 500 for punching sheet 500. Okay, then again select the same, assign load data point loads. Now this is live 797.6, column size is same. Now we go to sit. C2 dead load is 3013.3. Okay, go next to C3. Say dead load is 2760.8. 2760.8. Okay, then again stay. Here it will be live load. Say 1302.2. Okay, now we'll move to C4. Select symbol. 438.9 live load. And we'll select the same. 1000.6 dead load. Now column number C5. Dead load 3302. 3302.7. No, live load C5 1534. 1534.4. It's okay. This C6 and C7 in 600 by 600. So we will apply load later. Now C8 is selected. Assign C8 live load is the 1300.3. 3. Again select. Now dead load 2752.1. Okay. Now C9. Dead load is 3128.8. Here live load 1426.6. Now C10 and C11 both are 600 millimeter by 600 millimeter columns, so we will do later. We will go to C12. Live load is 1425.6. 1425.6. Okay. It will again select. Now we will give it dead load 2969. Now we will go to this C13. $1,044.8, 44.8. Again select the same. 453.6. Now C14. The load is 2819.5, 2019.5. Now live load 1320.7, 1320.7. Uh, C14. And 281.5. Here, make mistake. C13. And mistake when C13 as dead load. So here we 13. C15. 1433.9. here it is dead load 2996.1. 1700, 1764.1. Live load 769.8. Okay. Now we will select 600 by 600 millimeters. The C6. C6. C6 dead load is 5414.9, 5414.9. Here the size of load is 600. This is also 600. We again select. Here live load 2700, 2797.8. Okay. Now C7. C7 live load will be 2579.8. Here dead load it will be 4977.2. Now C10. Dead load is 5154.6. Now it's live load. C10 live load 2644. Now C11. Dead load 5191.3. 5191.3. Okay. Live load 2709.1. Now all the live and dead loads are assigned to columns. Now we can check this. Right click, loads. This is the job given. Okay. Here also loads 5639 13. Here C14 column some mistake has taken. So dead load is shown 5639, but it will be 2819.5. We will change it. Column number 14. Assign load data point load. Replace existing loads 2819.5. Here it is 500. It is also 500. Here it is dead load. Okay, now we will check it whether it is correct. give it 19.5, 1320.7, it's correct. Here also we will check 2969, okay, correct. 1433.9, correct. Okay, here also 1764, 769, okay, okay. So all the loads are assigned. Likewise, we can check all the loads we are assigned. Now we will right click here. Will the footing rebar material will be changed to HYS 500. Okay, okay. Now we will given strips here. It is strips HYSD. Okay, okay. Here likewise we will change wall strips. X direction, yes, all are selected, and even now strip B, layer B will be selected. HYSD 500. Okay, 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 okay. USB give rebars material to all the strips. All the details are given. Loads are given. Strip details are given. You can check the columns whether it will the rebar property are okay. HYSD 500 as given to all columns. So everything is given. Now we will run analysis. Run analysis. So we will save this as final project. this take analysis take to build. Now here this is given the displacement shown displacement of dead load. So we will run analysis and design. It has done. So we will check whether it is punching shear. Here punching shear we are living from that maximum are above 1, so we will change the thickness of footing. Now for that we will unlock and define slab property modifies. Here this 500 we will be given 900. Go on OK. Now run analysis and design. Now we will check whether show punching shear design is okay or not. Now also it will be shown that some columns here 1.46, 1.52, 1.58, 1.50, these are all above 1. So we will again change the thickness. So for that we'll go for define slab property modify. This time we will give 1200 mm thickness. Click on OK. OK. Now run analysis and design. Now display show punching shear. Now we can see that all the are under 1. So now the footing is designed and everything is clear. For it is smaller than 1, all values. Now we will see the set display option, extruded view, 3D view. Here we can see all the columns punching shear is all even. Now we will go again and extrude view. Now we will go to display show strip forces. This load is dead selected moment, show values and design. Here is the moment as shown for the load case dead load, and likewise we can change live loads. For live load these are all the values, we can check on this. And for load combination 1, these are all the values, and likewise for combination 2 we can see all the values of moment. Likewise we can we check shear forces also. These are the shear forces which is shown. This is for dead loads. Yeah, now we will check display show crack width. Here the load case is dead. Apply. As a dead case, it's every color in the shown somewhere is the values here. So here we can see e minus 3, 10 to the power minus 3 is a very small value. So we can, it is almost everything is safe. So we likewise we can use live loads also. So can this is also like a load combination. Likewise we can also check the load combination crack width. Mm, close. Now we will run detailing. Go to run and run detailing. All the three are selected. Okay. Now the detailing is done by the software. Here, drawing component views, slab views, framing plan is already shown. Mm, rebar tables. Here is the rebar tables is given. Rebar tables is given. Bar mark, cut length, total length, or like rebar schedule. Here is the total rebar schedule is here. Bill of quantities. Bill of quantities. Total bill of quantities record is given. Now individual slab views. Slab 1 rebar plan. This is the rebar plan given. Top rebar plan is like this. This is given. Bottom rebar plan. Top rebar plan. Section 1. Reinforcement profile on layer A. Reinforcement profile for layer B. So like this we are completed the detailing also, and like this the project is completed. Thank you very much.